Okay guys, before we move on with our inequalities, I want to get you to think about some revision of things that you should already know. So we're talking about actual equations this time, so not inequalities with a greater than or less than symbol, but an equation is something that has an actual equal sign. All right, so the first thing to remember about an equation is they have equal signs. And you should be writing this down in your book, not just watching. So if you need to press pause to catch up, please do that. They have equal signs. And we can think of equations like a set of scales, something that you weigh, an old-fashioned set of scales that you weigh on. And I like to draw a symbol for the scales. So let's imagine this is our set of scales. So there's a little stand here, okay? And we hang something on this side of the scales, and we can hang something on that side of the scales, okay? And this middle section here, when these scales are balanced, if I do it this way, when these scales are balanced, we say that the two sides are equal, all right? So if I put 3 chocolates on this side of the scales, you would imagine that if this side was empty, that it would go down, okay? And that would be not equal, all right? But if I put 3 chocolates on that side of the scales as well, you can see that these scales would balance, okay? So we could say that 3 equals 3, and we know that's true, don't we? So if you were to eat 2 of these chocolates, so we're going to take 2 away from this side, this would equal 1. What you have to actually do from the other side of the scales to make this equation true is the same thing. You have to take 2 from this side and you'll get 1, okay? We say if we take 2 away from the left-hand side of the equation, we must take 2 away from the right-hand side, otherwise it won't be equal. It won't be an equation anymore, alrighty? So let's look at something that's it's a bit more complicated. I am going to just redraw my scales here, just roughly. Make my triangles a little bit bigger because I got to put some more information in them this time. All right. Let's say that on this side of the scales we have a number plus 2. Now we don't know what this number is, so we're going to call it x. Okay, that's what algebra is all about. And then we're going to say that it's going to be equal to 7. So something plus 2 equals 7. Now I know that you can simply get a 5 and stick that there, but the algebra is going to get more and more difficult as we go. So what I need you to keep in mind is even though we're using really simple numbers at the moment, it's going to get much more complicated. All right. So when solving these types of equations with pronumerals, that's what the x is called, you must isolate the unknown. You do this by doing the inverse or the opposite operation. So the inverse of plus 2, or the opposite of plus 2, is minusing 2. So let's minus 2 from this side of the scales. X plus 2 minus 2. X plus 2 minus 2 is simply going to equal x, right? If you take 2 away from this side of the scales, all that's going to be left on the scales is the x. So we've got x by itself. We have isolated x, got it by itself. But remember, in order to keep these scales balanced, whatever we've done to this side, we actually have to do to this side. So over here we've got 7 minus 2 equals 5. All right, so now we've actually solved this equation. 3 dots means therefore. Therefore, x equals 5. Okay? So just to go over that again, the inverse operation of plus 2 is negative 2. So if we take 2 from both sides, we are actually isolating x, okay? Isolate x. And I often say this little thing in maths class, what is the name of the game? The name of the game is to isolate x. In other words, get x on one side of the equation and get all the numbers on the other side of the equation, because then what we get is a value for x. Isolate x is another way of saying get x by itself. Generally on the left-hand side of the equation, not always. All right, so this system allows us to solve unknown sides. This gets us to be able to solve equations, basically. And there are slightly different rules for inequalities, but we're just doing revision at the moment, okay? So let's have a look at some really easy ones. Let's look at, without drawing all these scales all the time, because that's not practical, here's a few little examples. The first one, x plus 2 equals 3. Okay, and at this point, I will say to you, look, I know that you know that 1 plus 2 equals 3. I get that. But what I want you to do is use the maths strategy that I'm teaching you to solve it. So what's the name of the game? Well, the name of the game is to isolate x. And in other words, let's get x on the left-hand side of the equation and all the numbers on the other side. So obviously to get x by itself, we have to get rid of this plus 2. Right, the plus goes with the 2. And in order to do that, we have to think about what is the inverse operation of plus 2? Well, it's minus 2, okay? The inverse of plus, or the opposite of plus, is minus. So let's take 2 from this side of the equation. X plus 2 minus 2. And whatever we do to one side of the scale or the equation, we must do to the other side. So it's going to be 3 minus 2. X plus 2 minus 2, well, that's just x. 3 minus 2 is 1. So you can see that you have solved this mathematically. All right, let's do one more fairly easy one. Just lining up my book here. It's a bit difficult, bear with me. Let's do x minus 2 equals 3. So some number minus 2 equals 3. What's the name of the game? The name of the game is to isolate x. What does that mean? It means get x by itself. In other words, we want x on one side of the equation and all the numbers and the maths on the other side of the equation. That way we can do the mathematics and solve for x. All right, let's circle minus 2 and ask ourselves, what is the inverse operation of minus 2? Well, it's plus 2. So x minus 2 plus 2 just leaves us with x. Do you see how I'm not writing that out in full like I did before? I'm doing that little bit in my head, putting our equal signs underneath each other so it's easy for your teacher to mark your exam. So x minus 2 plus 2 is x, and then whatever you did to this side, you do to the other side. 3 plus 2, therefore x equals 5. Let's go back to the beginning here and check our answer. 5 minus 2 equals 3, so we know we've done the right thing. All right, moving on. We're not always going to be given nice, easy addition and subtraction. Sometimes you'll be given something with multiplication or division in it. So let's have a look at that one. Let's look at 2x equals 8. Now remember, these are equations, not inequalities, and we know they're equations because they have an equal sign. All right, what's the name of the game? The name of the game is to isolate x. In other words, get x by itself. What we want is x on one side of the equation or the equal sign and all the numbers on the other side so that we can do the maths and find out a value for x. Now what you need to remember is in between this 2 and the x, this pronumeral x, there is a mathematical sign, and actually it is multiply. So in here there is a little hidden multiplication sign, all right? You can write it in a different color if you want to remind yourself that between the 2 and the x there's a multiplication sign. All right, what's the name of the game? To isolate x. What do we need to do to get x by itself? Well, we need to do the inverse operation of times 2. The inverse operation of times 2 is divided by 2. So the way we do division in algebra is we write it as a fraction. So 2x divided by 2, and what we do to one side, we do to the other. 8 divided by 2. That is a nice, easy one because we can just go, how many 2's are in 2? 1. How many 2's are in 2? 1. How many 2's are in 8? 4. How many 2's are in 2? 1. So now we've got 1x equals 4 over 1. And I'm sure you know that in algebra, we don't have to write that number 1. X is the same as 1x. And we also don't have to write a fraction here because any number over 1 is itself. So x equals 4. All right? So these are a little bit more complicated, but I'm sure this is all coming back to you. Okay, the next one we want to have a look at is a division. So let's do x over 2 equals 8. So what's the name of the game? The name of the game is to isolate x. How do we isolate x? Well, it means getting x by itself. And we use inverse or opposite operations to do that. So what's happening here? It's actually x divided by 2 because fractions are divisions. And we're going to write over here the inverse operation of divided by 2 is multiplied by 2. So we're going to multiply both sides by 2. And the way to do that in algebra is x over 2 times 2 over 1 equals 8 times 2. Remember, we've got to times both sides by 2. All right. So x times 2 is 2x. 2 times 1 is 2. 8 times 2 is 16, and we can cancel these out just like we did back up here. It's the same thing. How many 2's in 2? 1. How many 2's in 2? 1. Basically, you're left with x equals 16. Let's have a look and see if this is true. There's a way of checking it. We supplement 16 back to where x is. So 16 divided by 2 equals 8. Does it? Yes, it does. 16 divided by 2 is 8. Perfect. So there's a way of checking your answer. If we did that for this one here, x is 4. 2 times 4 is 8. So 2x equals 8. Perfect. It works perfectly. Okay, so that's a little bit of revision of inverse operations and isolating x.